Hello, everyone. My name is Hemant Tripathi, and in this very short presentation, I'm going to share some key information from our agroecology study, which we conducted as part of the AFRICAP research project. The primary goal of climate smart agriculture, or CSA, is to achieve triple wins by contributing to three objectives: increasing productivity, increasing the resilience of food production, and mitigating greenhouse gas emissions. However, there are gaps in evaluating the success of CSA approaches, as studies have predominantly focused on productivity outcomes. With such a narrow agricultural productivity focus, the possible impacts of CSA practices on other components, such as biodiversity and ecosystem service provisioning that underpin agricultural system resilience and environmental sustainability, has been often overlooked and is a key knowledge gap. Evaluation of these broader components would help to develop a better understanding of the system level effectiveness of and also the trade-offs associated with the CSA. In this study, therefore, we evaluated the effects of local scale farm management, including CSA practices on invertebrate diversity and agricultural yields, focusing primarily on pest prevalence and suppression by biocontrol in the east of Sambara Mountains of Tanzania. Specifically, we examined relationships among richness, abundance, and body size of crop pests and natural enemies, percentage crop damage and crop yields, and also annual income from crops under varying combinations of CSA and traditional farm management practices. What do we find? Our study identifies mulching and farniya jute trenches as CSA practices with potential for maximizing synergies among food production, biodiversity conservation, and pest suppression via biocontrol. Furthermore, it also shows that increasing inter-row spacing of maize to 70 to 100 centimeter and integrating food crops like maize and beans with cash crops such as spice plantations improves grain yield and annual income of farmers. Broadly, our study highlights the importance of local management and landscape characteristics in maintaining biodiversity in agricultural landscapes. Our study also uncovered the real risk of negative impacts of CSA interventions and maladaptation on farmer livelihoods. In this study, increased pest richness and abundance, lower yields, and income were evident in local variety fields neighboring those where improved varieties were used, suggesting the use of improved varieties by farmers is creating increased vulnerability among neighboring farmers. The need for further research on assessing biodiversity impacts and for holistic and long-term evaluation and monitoring of CSA across field and landscape scales is therefore very clear. CSA evaluations must look beyond productivity alone because the trade-offs and synergies among biodiversity, agricultural production, and food security, livelihoods, and health often interact and feed back on each other in possible complex and unexpected ways. For more information on my research, you can write to me on hgtripathi05@gmail.com.